This is the Fairchild Channel F video game console. This is from 1976. It is the first video game console to take cartridges. So yes, this predated the Atari 2600 by about a year. And yeah, it's kind of an interesting system. It actually uses bitmap graphics, which is pretty crazy considering how expensive RAM was back then. This particular unit has a couple issues. Apparently the power supply failed while it was running, and the person who wants me to fix it also wants me to attempt a composite video mod. So let's take a look inside the box and see what else this came with and see if we can get it going. Let's get started. Oh look, there's Bud.
Look at this advertisement with all these random people and a baby. This seems like something like from the 90s, but it's 1976. It's nib in box. Now this is definitely the 70s. Yeah, so this would have been 1 year before the Atari 2600. And the controllers are very unique. They're joysticks, but they also twist and turn like this, and then they also go up and down. It has some built-in games, I think like 2, but it also takes cartridges. So here's one of the cartridges. Now, fellow YouTubers, especially YouTube game journalists, see my air quotes, 1976, this game cost $20. And that's in line with what Atari games cost 5 or 6 years later. So when you're whining about a $60 game in 2021 having microtransactions, hello, inflation? How can a $60 AAA game still have microtransactions? I'm a YouTuber. I'm serious, all these YouTubers, were they like infants back in 1990? Like, I remember going to a KB toy store and guess what? Genesis games were 50 bucks in 1990. That's like $100 today. Hashtag inflation. But what about the economies of scale? Grand Theft Auto sold 100 million units. Yeah, Grand Theft Auto sold 100 million units. Most games don't. You've got a $36 game on the Atari 2600 programmed by one person in 6 months versus a $60 game programmed by 500 people over the course of 3 years. Let me get off my soapbox. All right. Oh, it's got a lid, kind of like the 5200. Here are the controllers. Look at this. Which way is forward? Who knows? But yeah, look, you can do this. You can also do this, and you can do that. Look at that. Oh, look at this beefy boy. Beefosaurus Rex. It's outputting 2 voltages. Holy crap. 16 amps on the 10 volt line. Output red, yellow, 15 volts, alternating current, 3.75 volt amps. Black or blue and white, 10 volts, alternating current, 16.7 volt amps. Okay. Oh my gosh. Actually, wait, I think I have one just over here. Fairchild Camera and Instrument Company. Made in America? Beauty! Oh, did they hide a screw underneath this foam bottom? Oh, they did! Oh man, I've been missing this practice. Oh. Ta-da! Oh, look at this. This off-the-shelf power supply here. It's going into this Molex. What? Look at that. There's a Molex. And then they've got these insulators going through the case, so I assume this would... Look at that! Isn't that crazy? And then they've soldered around it too. I guess they were making sure that they weren't having any... Well, they were being very careful about emissions in FCC. It was pretty common back then, like, you'd see so much plating on these things. Red, yellow, blue, white. So I guess we'll start by seeing if the power supply works. If you hear some grinding, that's the Roomba that I turned on to distract Bud. 2.6 volts AC. I think that's less. Wait, what did it say it was supposed to be? That seems awfully low. This is not giving us anywhere near the voltages it's supposed to. Red, yellow, blue, white. Yeah, that's how I tested it. I'm thinking it's the power supply. I mean, that is the most likely thing to fail on something this old. It's almost as old as I am. Smells like an old car inside. Oh, this is quite the sub-assembly. Oh, there's 2 sets? Oh, those screws are just going into the tin? Oh, really? I guess the question is, if the power supply is bad, can we get a replacement one, or can we use something else? I mean, does this thing actually use AC? I kind of doubt it. Which is why we should look inside and see if there's some bridge rectifiers. I mean, you'd think there would be. Although I don't know. Fairchild's a... that Roomba seems to have special programming where I turn it on, it immediately avoids the living room, goes down the hallway, goes into my bedroom, and then proceeds to be stuck in my bedroom until the battery dies. Lovely. Man, this thing is large. Alright. There's a speaker in it. I'm going to remove the ribbon cables to the cartridge, which you can't see. Okay. Oh man, this thing has definitely got a odor to it. A lot of integrated circuits for a video game console. It looks more like an Apple One. Oh, that's got an RF box. Let's see, these are all Fairchild. Date code is 77. Oh, good gravy train. There's another Molex on the bottom of those insulated pass-throughs. Wow. This is bizarre. Well, I see a regulator and 2 bridge rectifiers. So that means the 2 different analog voltages are being converted into DC. Technically, we don't need the cartridge slot to run this thing, because allegedly it has built-in games. Oh my gosh, there it is again. Look at that. It's a connector going to a connector, going insulated through the can. Oh man. The FCC must have been like really, really anal about this stuff back then. Look at this weird tape on the side. That's strange. There's a big can regulator over here. I'm guessing that's probably 5 volts. 12 volt regulator here. Under there. Then we got the 2 bridge rectifiers here. So the 2 ACs coming in. So there's one pair and then the other pair there. And let's see. Looks like this must be the power switch. So the power switch is disconnecting the transformed AC voltages and then allowing them to go to the bridge rectifiers, which will turn them into DC voltages. Yeah, so we have, see, this one goes here to that guy, and then the other side. So this one would go here. Yeah, okay. So there's the AC side of the bridge rectifier. Wait, how do you know that's ground? Oh, this plane isn't ground. Is it a power plane? Oh, that is a power plane. Oh, it's nicely labeled. Positive 12 volts. Yeah, so I'm thinking it's the power supply brick. Oh, look at the number on that can. It's a good old familiar 7805. Beauty! Use my PC bench power supply. Attach 5 volts here, 12 volts here, connect ground, and then see if I get any activity with the scope. But I think I'm going to eat lunch first. Let's get this lunch out onto a tray. Nice! Okay, this is the Wendy's Son of Baconator, because the Baconator father is just too much to eat. Bacon-based burger. It looks like you get some bacon and 2 square burger patties. Oh, let's take a look at the bacon here. Well, this would have been reheated bacon. Although it's cooked pretty consistently. That piece is kind of caught up there. Yeah, so they probably would get this bacon in at room temperature, and then they probably just microwave it like everything else. But yeah, you have 2 layers of bacon and cheese and patties. What did this meal cost? Oh my gosh, I think out the door, that was like $9.91. Maybe that Wendy's finally had to raise their wages. Alright, so apparently Wendy's has this new policy where if your fries aren't super hot, you can request new ones right at the window. These fries are fairly, I wouldn't say lukewarm, maybe like Leia warm. Oh my, that's like the dumbest thing I've ever said. But it's been kind of feisty lately. Look at this. Look at that. I haven't started an illicit drug habit, don't worry. Just beer. I think Wendy's changed their fries not that long ago. It feels like they have more of kind of like a textured coating. I wonder if that's how they can keep them hotter longer, and then they can have their fry guarantee. But I don't want to sit there at the window and be like, ooh, wait while I test my fries, peasant. Alright, let's try the burger. Yeah. The bacon's at a good crispiness level where you can definitely differentiate it from the meat. But it's crunchy, but it's not too stringy as well. And that way it chews with the meat quite properly. Yeah, the sauce is good too. Here you go. Now you can scan my teeth patterns and dox me. Sorry, I'm getting ready to do that test here, knocking everything off my power supply. What a mess. Ugh. Oh, I can't bear to hear Bud whining. Play loud music.
Here's a personalized loud station based on your listening history on Amazon Music.
Yeah, I guess this is the power switch. So there's no switch to change what channel it goes to? Oh, I hope I don't destroy anything. I don't know, are these things rare? Power's off. 12 volts. 5 volts. So what I'm going to check is I'm going to use the scope and I'm going to probe this line going into the RF box, which I'm assuming is composite video in right there. And we'll see what happens. Hopefully there's no magic smoke. Wait, how would you even see that LED? It's under the cartridge slot. All right, here goes nothing. LED comes on, that's good. It's time for a Bud cameo. Hello, humans! I am Bud, a cat from the future. I will attack the wobbly... Bud, you're making the puke cam more pukey. No, there's a current in that. Do we have any bus activity? Nothing there. Let's check this. Wait, there's something. It is a square wave. According to the Googles, these two are ROMs and this is the CPU. Let's see if I can get... Well, I saw a square wave on one of the ROMs, which makes me think the CPU should be doing something. Okay, there's a data signal. It's an intermittent signal at 5 volts. That's a good sign. Wait a minute. Maybe... Oh, maybe this is just the power input to the RF regulator. Yeah, because this is a straight 5 volts. Is this thing in color? I think it is. Don't worry, I'll put my scope on the screen just a second here. Okay, frequency is 15.98 kilohertz. That's odd. So one of these should combine all... Oh, there we go. There is... You know what? I should show you the scope. 15.98 kilohertz. That's weird. That's faster than it should be. I mean, it seems like it's inverse. Like that there looks like it should be. That there is a whale. That there looks like it would be the horizontal blanking pulse, but it's high instead of low. I did notice some stuff coming into this part of the can here. Oh, that's a color burst frequency. 3.5 something something. Yeah, I haven't found a composite yet. Oh, that looks... Okay, that's looking closer. I have no idea what happens when you boot one of these machines, but yeah, so there's there's your horizontal sync pulse. There's your back porch, and there's your... I guess it's a bright color. In an NTSC signal, what they do is they take the color burst frequency and they put a color burst reference right here. So the color television picks that up, and then it uses that as a line-by-line reference for the color phase variations that it actually sees in the pixels. That's why on the old Atari 2600, there's a big potentiometer on it, which actually adjusted the phase of the color burst. So if you twisted it, the color burst, and by phase I mean like where the waveform appears in time. If it moves a little bit, that creates a different color. And you could consider it a tint control. Are you a large loaf? Large loaf. Nope, there's no food left over. No, don't wreck that. That's the rare game case. This looks like a pretty valid NTSC signal, although it looks like it's mostly white. Is there any variation? Also, I'm not seeing color burst. I wonder where are they adding the color burst? I think, yeah, this thing is in color. I'm telling you, this old camcorder is so useful. Okay, there's something on the screen. I don't know what it means. Oh, I pushed a button and it went away. Whoa! Okay, something's happening. I'll just go all Blade Runner. Zoom in. Quadrant 16A. Rotate 90 degrees. Pan left. Truck forward. Stop. Maybe we haven't tapped just the right point, but I definitely can see some paddles and a barrier and I believe a score. Oh, look, the ball's moving. I don't think we're tapping the best point for a composite video signal, but it was just the first one that I found. Wow, I just looked it up. This thing has a 2K frame buffer. It's like 128 by 64 pixels by 2 bits per pixel. So 128 times 64 is 8,192 divided by 4 would be 2,048. So yeah, 2K. And these are the RAM chips here. So yeah, it must. I wonder if it's kind of working like the ZX80, where the CPU is basically drawing the screen using the frame buffer, which, well, exactly. So I'm just going to resocket these to make sure that they're all kosher, because this thing is old. I had a space shuttle pinball, and the ROM chips in it, sometimes they would creep. So pushing them back in would get it to run again. Not a ton of electrolytic caps, but there's a few. I don't have any replacement 47s, but I have a 100 and a 4.7, so I'll go ahead and swap those out. I looked at some videos. Yeah, it seems like the background should be a color, not black. I swapped what caps I could. I just realized that, yeah, there's no amplification on this video signal. That's why it appeared, well, the camcorder attenuated it. Oh, look, another hidden LED inside of the RF can. What? That video circuit didn't work. I'm going to have to order some different transistors online, so we'll just jump to a few days from now. Bud, are you in your favorite basement spot? Yeah. Sleeping on all the packing materials. I went online to Channel F.se VESWiki and found a diagram for a video amplification circuit, so I've hooked that up. Got this camcorder here, of course. And let's see if it works. Let's turn on the camcorder. And then we got the scope hooked up. Turn on the channel F. Yeah, we get signal. There's a potentiometer on the circuit to adjust it, but this looks pretty good. 1 volt peak to peak. The color burst isn't super obvious. I mean, it's there, but it's pretty light. Wow, it drew a playfield. Great! Yeah, so this is actually a bit-mapped playfield. 128 by 60, so there's like 2K of RAM, which actually holds the playfield. So if I had to guess, the CPU is basically just manually rastering out the screen memory here over the video circuit. So it probably works in a way similar to the ZX80, where there's no dedicated video chip. The CPU just spends a lot of its time drawing the screen. Let's check the actual currents, not the ones the power supply claims to need. 5 volt, looks like about 800 milliamps. And 12 volt is, drum roll, 110 milliamps. I bet the only thing that the 12 volt is doing is probably powering the RAM. Yeah, this power supply is way overkill. All right, well, now that I know these numbers, I think what I'm going to do is maybe get a couple switchers, like a switching 12 and a switching 5, and then find a power brick that's got like 14 or so. Input that, knock it down to 5 and 12, and then just pipe it in. So basically we'll skip all the AC stuff entirely. I found a 12 volt power supply in my box that actually outputs 16 volts. I think that's a good choice. So what I'm going to do is I'm going to remove pretty much all of this AC stuff. I think I'm also going to remove the 5 volt regulator. My plan is to use a 12 volt switching package. So we'll put 16 into the switch, so the switch will no longer be AC. 16 volts into the switch, it'll go to the 12 volt switcher, knock it down to 12, and then we'll take that 12 and send it along its way. I'm sure it goes to the RAM. And then we'll use that 12 to power the 5, probably use the switcher again. That's why I want to remove this regulator, because the drop from 12 to 5, 7 volts with an old school regulator is going to generate a lot of heat. So I want to modernize that. Looks like a pretty standard regulator. Ground in the middle, input on the left, output on the right. I'm going to double check the data sheet, but I'm going to replace it with this. This is a 12 volt switching regulator package from Murata. Pinout should be the same, so these are intended as a drop-in replacement for a TO220 package such as this. Yeah, so what I'm going to do is I think I'm going to have this one right here. That's going to be the 16 volts in. that'll go through the switch. Then the switch, I believe, goes to one of these rectifiers. So I'll jump the rectifier right over to the regulator. And then we'll take the 12 volt output and attach it to the 5 volt regulator, which I haven't added yet. That's us! We're the Ninja Turtles! We live in New York City and we love pizza! Hey, what kind of pizza should we order? How about Domino's? So I'm actually gonna just put some headers in there. Probably need to do that the other way around. Oh, wait a minute. I need to be careful with this because I don't know if this thing has plated through holes or not. Oh, it should? It's not that old. All right, I'll do it this way just to be sure. I'll attach the header, the vertical header, not the right angle one that was on it, because it came with this right angle header. Then I'll actually remove the shroud part of it. Well, I guess it's not technically the shroud, but the block thing. Come on. Happy little clouds. There we go. Then I can install it just like that. That's why I wanted to remove that shroud, because I wanted to ensure that the connections were made on top, just in case the plated through holes were damaged. The plated through holes when you have a via and it has, well, it's plated through the hole and it connects the traces on the front of the circuit board to the back of the circuit board. But when you desolder things, often the plated through hole will get ripped out or destroyed. So in this case, I mean, I'm pretty sure the plated through hole is okay, but I just wanted to double check. I wanted to do it in such a way that would accommodate if the plated through hole is damaged. Okay, so if the switch is to the left, this should be connected. All right, cool. So that's going to be our 16 volts in. So we're going to take that. We're going to take it over to the input of the regulator. Then we need to find a place for the 5 volt regulator, and then we should be good. I just have to bridge together the two bridge rectifiers. It's very meta. I want you to live in the Facebook universe. Here's another one of these packages. This is a 5 volt version. So the 5 volts needs to go here. Oh, there's a big honking 5 volt trace in the bottom. That's all 5 volts right there. It's kind of a weird practice. They really wouldn't. Well, I guess they would do it. It would just be an internal plane now. Okay, I think this should work. 16 volts in here goes to the switch. 16 volts goes into 12 volt regulator. 12 volt comes out. The 12 volt is also fed to the 5 volt regulator. 5 volt comes out, and it goes to the 5 volt input. That's pretty common. You kind of step down your voltages, so yeah, you want to have the smallest delta possible between the input voltage and the output voltage. So 12 to 5 is better than 16 to 5. Let's give it a try. G question mark? Oh wow, look at that action. Amaze! I really hate these kind of ribbon cables. They really suck. These are so old, all the glue is delaminated, so I actually use some double-sided tape to stick the contacts back down, because basically I have like 2 pieces of plastic and then strips of metal in between. It's really flimsy and rinky-dink, but hopefully that fixed it. I also reinforced these cables with some Captain tape to make it stiffer to reinsert. Now let's see if it works. What does this button do? Oh look, we got a different game. Cut? Oh, so it must be cutting the deck? Okay, cool. Well, the cartridge slot works. Great! Wait, does the eject not work? Eject! Oh, so fun fact, this camera is the one I used on my original GeoCities website. Like, you could put it into photo mode. Can't remember exactly how it worked. But you push this button, and it would take stills into its internal memory, and then you would get them out using this digital I/O port. Yeah, so this camera took all, this camera took all the pictures from our website, probably until like 2003, I want to say. And this camera is great because it's like a Rosetta Stone. It's got FireWire right there. So what you can do is you can actually put, this is a digital 8 camera. It takes a high 8mm tape, which is a analog format, and it stores digital video on it. Turn it. Oh, there we go. Right. But the cool killer app is you can put in regular 8mm tape or high 8mm tape, and then you can play it, and then it'll export it digitally over FireWire. So this camera is actually still worth a couple $100 because it's like a Rosetta Stone. The DCR TVR 510. Yeah, this camera is now 22 years old and it still works. This case assembly is incredibly obtuse, but I guess it was the infancy. Well, yeah, it wasn't even the infancy. This was like the sperm of cartridge-based video game systems. All right, I put the gross rubber strips back on. There should be like an arrow, like pointing which way. What happens if you do that? Okay, it stops you. What happens if you do that? That's a bit sketch. So check out this funky joystick. Okay, so it's got left, right, up, down. I can also twist it, and look how it twists my paddle. See that? Oh, but that's not all. I can push up and down. Look at that. That moves my goalie. Oh my gosh. I mean, I'm actually kind of surprised this has a bitmap display in 1976. That's a lot of RAM. Oh, let me see if I can set my opponent up for failure. This seems more like hockey to me. Oh, there we go. I win! This appears to be some sort of shooting gallery game. Desert Fox Shooting Gallery. Okay. Nothing. Something's loose in there. Game 1. Okay, that cartridge works. Yeah, something's... I need to double check this. Something is like shorting out or something. This thing isn't exactly a paradigm of construction prowess. I had to actually loosen these screws and move this assembly a little bit forward because the eject lever was hitting the case. But now it should work. Beauty. That's a Bobby win. Oh, man, this thing smells like an old car mixed with like burnt enamel wire. What was this obsession with like being able to fit the controllers inside of the console? Like the 5200 did that, the ColecoVision did that. It just makes the console unnecessarily large. Oh, who knows? And we got this really cool cover that just goes over it. There's no hinge or anything. Budge, did we test it out on the big TV? I guess that's a yes. Oh, wow. Okay. So I think G means game. So let's go with hockey. Now, see how slowly it draws the screen? So even though this thing actually has a raster bitmap buffer, I think it would have been really slow because I'm guessing the CPU is actually driving the video image, which would greatly reduce the amount of time it has to actually update the screen. So even though this actually has far more RAM than the Atari 2600 as far as how quickly it can change things on screen, it's a lot slower. Now, Michael Scarn knew he had to save the championship hockey game. Let's play tennis, which is probably going to be just like hockey, but without a goalie. Oh, also you can't twist your players. So it's really just Pong. Although Pong is technically called table tennis. So yeah, I believe this is like 128 by 64 bitmap resolution, and then it's 2 bits per pixel. Well, wait, let's do the math on this. All right, if we do the math, resolution 128 by 64 is 8,192 bits, which is 1 kilobyte. All right, that makes sense. So it's 2 kilobytes, so it's 2 bits per pixel. That's where you get the color. So it looks like you've got like black, white. Well, yeah, you'd have 4 colors. Yeah, you'd have 00, 01, 1011. 2K is actually a lot of RAM for something in 1976, especially like a toy. Okay, the very first video game console to take cartridges, and we were able to get it working. We fixed the power supply issue, and then we added a composite video output jack. So now this thing is ready for another... How is this thing? It's 1 year
younger than me. I'm 46. This thing is 45 years old. Oh my gosh. This thing is almost a half century old. Isn't that crazy? I'm also almost a half century old. Isn't that crazy? Do you think your iPhone is going to work in 45 years? Anyway, I hope you enjoyed this repair and look inside a very important part of video game history. We'll see you in the next video. Look what you did. Oh, it's the automatic feeder. He's like, screw you, human. I've got food. This automatic feeder is useful because I don't have to like feed him before I wake up if I want to like sleep in on the weekends. At the same time, his behavior has changed since I've installed it. I wonder if I've taken away my brownie points by disassociating myself with food. I don't know. I'll have to run some more tests.